our share, that is not going to work. So the element has to match exactly, and then you will get back a true result. So that's how you check if something is part of a list. And then to combine two or more lists, again, pretty straightforward. You simply take a list and then you say fruits, and then you use a plus symbol, and then you put in another list, and then you put in one more if you want to. You can concatenate or combine any number of lists. We have the combined list now. There are also certain methods that you can use on lists. So for instance, there is a copy method that is used to create a copy of a list. And then there is a remove method. And then there is a pop method. These are things that we have seen. So you can try out more of these methods, and I've provided a link here. And try to use these methods to answer these questions. Reversing the elements of a list is one. Adding elements from one list at the end of another list, sorting a list of strings in alphabetical order, and sorting a list of numbers in decreasing order. So just see if you can check out these references and you can do these exercises. And if you cannot, then a good place to discuss or post where you are getting stuck would be the lecture forum thread. There's a lot of activity going on there. So just post your question and somebody will answer your question. Now, similar to lists, there is another data structure called tuple. And the difference between lists and tuples is that tuples are immutable, which means they cannot be modified once they have been created. Here I'm creating a tuple, and the way to create a tuple is instead of a square bracket, you simply use a round bracket, parentheses. And they support very similar operations, like you can check the length. The length is 3. You can check an element with a positive index, with a negative index. You can check if a fruit contains an element. So the dates is a part of fruits. But what happens if you try to change an element? So if I try to set fruits 0 to avocado, that is going to give you an error. And you cannot append to a tuple, and you cannot remove elements from a tuple. Okay, so that's one of the key differences. So we use tuples when we want to make sure that a list of elements cannot get modified. And we use lists when we can allow modifications, when we want some flexibility. So that's about tuples. And then there is a little more that you can explore here about tuples. And you can convert tuples to lists and lists to tuples and back and forth. There is no difference here. And just like lists, tuples have some methods as well, but a fairly limited number of methods. And finally, I want to talk about dictionaries. A dictionary is an unordered collection of values. So there is no specific order to the values stored in a dictionary. Now, if you do not have order, how do you access these values? So what dictionaries have is that apart from values that you put into the dictionary, they also have keys. In a sense, it is a lookup table. So this is how you create a dictionary. You open a curly bracket or a brace, it's called, and then you close a brace, and between the brace, you create key value pairs. Typically, keys are strings. So you have a key here, and then that key points to a certain value. And the value can be of any data type. The key name points to the value John Doe, and the key sex points to the value male, and the key age points to the value 32, and the key married points to true. So this is a much nicer way of storing information, let's say about a person, rather than just putting all the values in a list, because then you would have to remember what the first element represents and what the second element represents and so on. But here we have encoded it into the dictionary itself. So I've created a dictionary here. And now if I do person1, you can see that all these keys and values are present in the dictionary. And then there's another way to create the dictionary using the dict function, which has more of a function invocation syntax, but it does the same thing. So here you can see that just like person1, we have created a person2 with a different name, sex, age, and married keys. But the type of each of these is a dict. So there you go. Now, when you want to access a value from a dictionary, you do it by providing the key. So you need to know what keys you want to access. If I want to access the name of person1, I use the same indexing notation, which is the square bracket, and then I simply put in the key. So here I put in the key name, and when I run it, I get back John Doe. Similarly, when you do person1 married, you get back true, and then person2 name, you are getting back Jane Judy. And if a key isn't present in the dictionary, you get a key error. Okay. Now, if you want to avoid a key error, you can use the get method. So again, from person2, if I try to get the address key, which does not exist, I can use a get method, and I can provide a default value that can be returned if the dictionary does not contain that key. You can check whether a key is present in the dictionary. So this is checking keys, not values. So whether a key is present in the dictionary using the in operator. So name exists in person 1, but address does not exist in person 1. So that's how you get values out of a dictionary. Then next, you can also change the values associated with a key using the assignment operator. So here I'm using the assignment operator to set married for person 2 from false to true. And the assignment operator can also be used to just add new key value pair. So person 1 does not have an address. They have a name, sex, age, and married. But if I set person 1's address to 1 Penny Lane, now you can see that the address shows up here as well. And then dictionaries have certain methods. So dictionaries provide methods to access just the keys using dictionary.keys and access just the values or access the entire key value pairs. And then there are many other methods that dictionaries provide which you can try out, and we will use many of these in the future. Here are some experiments that you should try out with dictionaries. So what happens if you use the same key multiple times? How do you create a copy of a dictionary? How can you change the value associated with a key? Can you change it to be a dictionary itself? Can you have this kind of a hierarchical structure? And there are a couple more experiments. So do try these out. Again, I've left you some blank spaces to try these out. And then I've also linked to the Python documentation and then certain other tutorials where you can learn more about data types in Python. So with that, the last thing that we should do, since our notebook is running on an online platform, is we should import the Jovian library and then run jovian.commit with a project name. So I'm going to set my project name to variables live and just running jovian.commit. And now that is going to ask me for an API key, which I can get from my profile. So I just copy the API key. So once I'm logged into jovian.ml, I copy the API key and paste it back here. And what that does is that takes the notebook that we were just looking at and it captures a snapshot of that notebook and then it puts it onto your JovianML profile. So now we can close this, and then this is then now going to go away, this binder instance. But my Jupyter notebook is here for me to view whenever I need to. And I can go back and I can run it using the run button. So that's what we do. We run these notebooks on Binder, we make some changes, we bring them back on Jovian, and then we keep making changes. And that's how we start collecting different versions of the notebook. So all the updates that you make over time get recorded. So with that, we've completed our discussion of variables and data types. Let us move on to the next topic, which is branching and loops. We are going to continue working on the basics of Python. So let's get started. Where you should go is the course page 02pandas.com. We are doing lesson 2. So let's open up lesson 2. So lesson 2 page, you can open up conditional statements and loops. Once again, I'm just going to click the run button to run this on Binder. So here we go. Now we have the new notebook. I'm going to do kernel restart and clear output. And I am going to hide the toolbar, and we're ready to get started. So one of the really powerful features of programming languages is branching, and branching is the ability to make decisions and execute a different set of statements based on whether a condition is true. And what does that mean? I want to show you with an example. So here, the simplest way to introduce a branch in your code is to use the if statement, and which is written like this. So you say if, and then you put a condition after the if, and then you put in a colon. So this is to indicate that there is something below it. And now you can then put in a bunch of statements. And all of these statements, you have to give them a little bit of a space. So just give them 4 characters of space before the statement. So here there are 4 characters before statement, and then we have the statement itself. Then we have another statement, and all of these statements which are indented. So these 4 characters of space before a statement are called indentation. So all of these statements that are indented belong to the block, belong to an if block. And these statements get executed only when this condition is true. Okay, so let's look at an example of that. So here I have a number, and this number has the value 34. And now I'm writing an if statement followed by a block of code. So here I'm saying if a number which is 34, and this is the modulus operator which returns the remainder. So the remainder when 34 is divided by 2, so which will be 0 because 34 is even, if that remainder equals 0, so this entire condition, this entire expression returns true. So since this expression is true, then these statements get executed. So the statement we are inside an if block, and the statement print the given number, which is 34, is even. And notice that we are using string formatting here. So if I execute this, you will see that these statements get executed. Very simple, but a very powerful idea, and you will be doing this a lot. This is the bread and butter of programming, really, branching and looping. Let's try another example here. Now we have 33, and then with 33 we are once again checking if this condition is true, and if this condition is true, then we are going to try and print something. But you can see here nothing gets printed because this condition does not hold true. That is basically the if statement. And what you might want though is you might want to do one thing if the condition is true, and you might want to do another thing if the condition is false. And that is where the else statement comes into picture. So what you can do is you can have a if statement, and you can have a block of code after the if statement, and then you can write else and give a colon and have another block of code. So if the condition holds true, then the first set of statements is executed, and if the condition hold is false, then the second set of statements is executed. Okay, so let's check it out here. So we have a number, and we say that if a number divided by 2 leaves a remainder of 0, then we say that it is odd, otherwise we say that it is even. So here, since 34 is even, this gets printed, and then similarly, since 33 is odd, the second statement that the number is odd gets printed. Here is another example. So you can build these conditions in any way, so it does not just have to be arithmetic. Here is another example. I have a tuple, the 3 musketeers, and then I have a candidate. So what we do is we check whether a candidate is in the tuple, and that makes Python is so readable that you can just read this and understand what's going on here. So if a candidate in the 3 musketeers, then print that the candidate is a musketeer, otherwise print that the candidate is not. All right, so you can build these conditions and combine them in all sorts of complex ways, and that gives you a lot of power. Now, one other statement, which is, you may or may not use this a lot, but there is an elif statement that you can use. So when you want to check not just one condition, but a series of conditions, you can use the elif statement. So I'll just show you with an example what it does very quickly. So what we do is here is we say that if today is Sunday, then we print something about Sunday. Else, so else if, so elif is short for else if. So if this condition fails, then we check this condition and print something. And if that condition fails, then we check this condition. So as conditions keep failing, we keep checking the next condition. But if at any point a condition becomes true, so for instance, at today equals Wednesday, the condition becomes true, then we simply execute the code inside that block, and then we ignore all of these. All right. So that is the elif statement. Keep checking conditions until the condition is true. When the condition is true, execute the statements inside that block and then ignore the rest. Okay. And there are a few details here about elif and how it is different from simply using a bunch of chained if statements. So I will leave that for you as an exercise. So here we have tried the same thing with if elif, and then we've tried the same thing with just a bunch of if statements. So I'll let you try that out. And finally, you can use if, elif, and else together. So here I have the number 49. So what we do is we try to check if it is divisible by 2, and then we print it is divisible by 2. We check if it is divisible by 3, and we print that. We check if it is divisible by 5, and we print that. If none of these conditions hold true, then we go into the else block. So you can do a chain of if, elif, and else statements. Okay. And then finally, what you can also do, as I've mentioned before, is within an if statement, you can take this number and you can have a check on that number, and then you can do an AND. So you can combine two conditions. So you have a number divisible by remainder with 3 equals 0, and a number remainder with 5 equals 0. And then only both these conditions are true, you are going to go and execute this print statement that the number is divisible by 3 and 5. Okay. So that is the if else statement. Now, one other thing is that these conditions do not necessarily have to be conditions. In fact, they can be any value, and they can be any value in Python. For instance, it can be a string, it can be a dictionary, it can be none, it can be a number. And what happens is that Python automatically, whenever you put in a value that is not a Boolean, Python automatically calls the bool function on that value. And we've discussed this the last time in the last lecture, so you can look it up there. When you call the bool function, empty values like 0 or the empty string or empty dictionary or empty list get converted to false, and all other values get converted to true. So there are a certain set of falsy values, and there are a bunch of true values. Okay, and this is pretty useful because if you want to do a certain operation only if a particular list is not empty, then you can simply say if my list, and if my list is true, then you print something, else you print something else. So this is a very simple way to just check whether something is empty or not. And then again, a very minor thing, and you can try this out, is that you can have if statements inside if statements. So here is an if block. So we are checking if a number is divisible by 2 or not. And then inside the block, we have another if statement where we check whether the number is also divisible by 3 or not. And then what you have to do is this if statement itself has to be indented, and then the block inside it will require 2 levels of indentation because it is indented from an if statement which is already indented by 4 spaces. Okay, so check this out, try this out. First read this out line by line and try to predict what will happen as you put in a number here, which path it will follow. And as you change the number, try to see if you can get all of these print statements to show up in different cases. Okay, now one small piece of advice here is avoid nesting statements, if statements, wherever possible. So if inside if is very confusing. So the maximum you should go is maybe 1 level of nesting, and try to keep your code as simple to understand as possible. Okay, so that is the if. Those are all the variations of the if statement. And then there is also something called a shorthand if expression. This is not something that we are going to cover in the lecture, but again, this is here in the notebook. So if you're going through the notebook, you can try this out. Essentially what it offers is it offers a way to put the entire if, condition, statement, else statement, all of that into a single line, especially when you want to calculate a new value out of the if statement. Okay, so I will skip ahead for now. So I'm just going to save my notebook here because this is something that you should just do from time to time. Keep saving your notebooks. So here I just take my API key and paste it in here, and that uploads the notebook to Jovian. Okay, we've gotten a lot of comments about people losing their work on Binder because they left the tab open for a long time or left their computer for a while. So just keep running jovian.commit from time to time on Binder so that you do not have to deal with that problem. Okay. All right. So now we've looked at conditions. The next thing that we're going to look at is iteration. And iteration is an extension of condition or an extension of branching in a sense. So what it allows you to do is it allows you to run one statement or a set of statements multiple times. So we have something called the while loop in Python, which works like this. So you say while, and then you put in a condition, and then as long as that condition is true, so let's say you're checking the value of a variable, whether it's even or not, as long as that condition is true, the statements inside the while loop keep executing over and over again. And what you might normally do is that within one of these statements, you might change a variable, which might later cause the condition to become false. Okay, and that is when the while loop will end and we will continue with the execution of the program as normal. So let's take an example. You might be familiar with the concept of factorials. So what we will do is we will try to, the factorial of the number n is simply the product of all the numbers from 1 to n. So the factorial of 10 is 1, 2, 3, 4, 5, 6, all the way up to 10 multiplied and so on. So we will write a while loop to calculate the factorial of the number, or a factorial of the number 100. Okay, and so the way we're going to do this, we are going to create a variable called result. This is what will get back the final result of the factorial. And then we are going to create a variable called I, which is, you can call it index or you can call it like a counter. So I has the value 1, and then we create a while loop. So we say while I is less than or equal to 100, So initially, since I is 1, this condition is going to be true. So then these statements are going to get executed. So first we do result equals result times I. So since I is 1 right now, then result will continue to remain 1. And then we do I equals I plus 1. So I plus 1 is 2. So now we change the value of the variable I to I plus 1, which is 2. So now I has the value 2. So now we come back here. The statement, the condition is executed again. This condition is currently still true. So then we multiply the result with 2. So the result becomes 2. And then I now becomes 3. Then we check the condition again. And then we multiply result by 3. So result becomes 1 times 2 times 3. And 1 into 2 into 3. And then we have I gets increased to 4. And now you get the idea, right? We keep repeating this over and over till this condition becomes false. That is, till I becomes 101. And when I becomes 101, at that point, this condition is false. So at that point, we break out of this loop. So it's called breaking out of the loop. And then we can go on executing the program with the statements that follow it. Okay. So let's run this. So you can see we ran this and it took hardly an instant, and it gave us the factorial of 100. And you can check whether this is actually the factorial if you want to. You can look it up online. But that's basically how this code works. And the real powerful thing here is that just with these 4-5 lines of code, we have been able to calculate the factorial of 100. But if you want to go from 100 to 1000 or even 100,000, all we have to do is change this. And that is what makes computers really powerful, that with a few lines of code and with their real speed of arithmetic operations, they can compute a lot of different things very quickly. So here we have, for instance, here we are trying to calculate the factorial of 1000, and I've added this special command called %time. So this %time is simply going to tell us how long it took to execute this cell. So yeah, I run this cell and I get back 1000 factorial, which is this huge number, pretty huge. And it took only a total of 2 milliseconds, which is like a thousandth of a second almost, pretty much. So that's why loops are a really powerful thing in programming, because they let you process a lot of data really quickly with a few lines of code. So now here are some exercises that you can try out with the while loop. So with the while loop, here is a pattern that I've printed out. So I've just printed out this nice pattern using just asterisk characters. So that takes a couple of while loops to print this out. So try and see if you can understand what's going on here. See if you can make sense of this code, and then use that to maybe create a couple more patterns. So here is one more pattern. This is the mirror image of that pattern. And then here is like a diamond pattern or a rhombus, putting these two together. So try and see if you can write the code for these, especially this one. It can be a little bit tricky. So if you can figure this out, then you have really gotten a good hang of loops and iteration in Python. Okay. One other thing that you might want to keep track of is that sometimes you may make a mistake while writing your code. So here I am calculating factorial, but within my while loop, I may have forgotten to increment I. Okay. So when this happens, when you forget to increment, what happens is this condition remains true forever because I is not changing. And when you run this cell, now it's just going to keep on running continuously forever, and you will not be able to execute any other code in the notebook. So this is called an infinite loop because the program is stuck in the loop forever. And the way to come out of this is to interrupt this execution or to stop this execution. And there are a couple of ways to do that. So you can go kernel interrupt, and that's going to interrupt the loop, and then you can make the change and rerun the cell. And then the other option, and by the way, here is another example. Here what I've done is I am incrementing I. So again, we are calculating factorial and I am incrementing I, but I put in the wrong condition here. So this condition, again, I can keep on going to 1 million or 2 million, but I greater than 0 will always continue to hold true. So this goes into an infinite loop as well. So the other way to stop it is if you have the toolbar open, next to the run button, you have a stop or an interrupt button. So you can simply press the interrupt button and that is going to stop the execution. So those are the two ways that you can break out of these infinite loops. And don't worry, you can always go back and fix these things. So write your loops, and then if you see that it's going into an infinite loop, just interrupt and fix it and rerun it. Don't be afraid to get it right the first time. Now there is a couple more things within while loops. One is that there is a special statement called break. So what you can do with a break statement is, yes, you have this condition within a while loop, and this condition can, when the condition becomes false, you will break out of it. But sometimes you may want to, depending on a certain condition, depending on what values you are iterating upon, you may want to decide that, okay, I want to stop the execution of the loop somewhere in between. And that is when you use the if character. That is when you use the break statement. So for instance, here we have I equals 1, result equals 1. And then while I is less than equal to 100, we multiply I with the result. So this statement result star equals I is the same as result equals result star I. Okay. And then we have an if statement here, which checks that if I reaches the value 42, then we say that magic number 42 has been reached and we are going to stop the execution, and then we are going to break out of the loop. So this break gets executed, and then we exit the loop completely. And then we execute these statements, right? So you can see here that I at the end of the while loop has the value 42, and the result is not nearly as close to the factorial of 100 that we initially had. In fact, it will be 42 factorial exactly. So that is a break statement. And then there is another statement, that is the continue statement. So the continue statement is slightly different from break. What it does is it completely breaks out of the loop. But what the continue statement does is the continue statement. So here let's look at an example. So again, we have I equals 1, result equals 1. And then while I is less than 20, we increment I. So we go from I goes from 1 to 2. And then we check if I is even. So if I is divisible by 2, the remainder of I with 2 if it is 0. Then we print that we are skipping I, or whatever that number is. And then we have the continue statement. So what the continue statement does is that when this gets executed, anything else, all the remaining statements in the loop are skipped. So this print statement is skipped and this result multiplication statement is skipped. Okay. So let's try it out. Let's just run this. So you can see here we started out with I equals 1, and then we had I equals 2 in the first loop. So we skipped 2 because this if statement was true. And then we did, so there was no multiplication with 2, but then we did multiply with 3. Then we skipped 4, multiplied with 5, skipped 6, multiplied with 7, and so on. And the result that we get back ultimately is the product of all the odd numbers from 1 to 20. Okay, so that's the continue statement. So break and continue are, well, they're not very often used, but they're quite useful sometimes when you are stuck in a tricky loop where you want to somehow have something come out of the loop based on a certain condition. Okay. So those are loops, and I'm just going to run jovian.commit once again, just to save my work. So those are while loops. Another important kind of loop, in fact, something that you will probably be using the most often, is the for loop. Now, just as while loop is used to iterate while a condition is true, the for loop is used to iterate or loop over a sequence. For example, if you want to perform an operation for every element of a list or a tuple or a dictionary or every character in a string, that is when you use a for loop. And they have a very nice, simple, intuitive syntax. So what we say is for value in sequence. For value in sequence. So we have a sequence, and then we take, using the in operator, we take one by one each value from the sequence once we put it into this for statement, and then we can execute a bunch of statements repeatedly, a bunch of statements for each value from that sequence. Okay. And it'll become clear with an example. So here we have a list, and the list has Monday, Tuesday, Wednesday, Thursday, Friday. So it has these elements. These are all strings. And we say for day in days. So for day in days. So what happens is that every time for every element, Monday gets put into the variable day, and then you can print day. Then Tuesday gets put into the variable day, and then the statement gets executed. Then Wednesday gets put into the variable day, and then the statement gets executed, and so on. Okay. And you can see here, as you might expect, Monday, Tuesday, Wednesday, Thursday, Friday gets printed. And here are a couple more ways you can try this out. So we can actually loop over a string, and we can get back characters from the string. So for every character in the string, we print out the character. So here Monday becomes Monday. We can loop over a tuple or a list. This is more of a list than a tuple. So here we are going to loop over the list apple, banana, guava, and then we are going to print it out saying here's a fruit. So here's a fruit, apple, banana, and guava. We can loop over a dictionary as well, which is again something that we will do a lot over the course of the next few lectures. So here we have a dictionary, and then we are going to use the name John Doe.